And now for the magic trick. What happens when Company Z pays people the 900,000 euros? It may pay a plumber, a labourer, a supplier, etc., who in turn deposit the money in their respective banks. Now I will very clearly and simply explain the phenomenon of the bank multiplier. What are D and D1? They are the original deposits, while X is credit expansion. E is the reserve ratio, which we are supposing in these examples is 10%, and K is the proportion of loan funds which, at any particular time, on average, borrowers leave unused. Company Z may not pay out all of the money. It may use only 80% of 900,000. Or it may pay out the whole amount. And yet 20% of the people who receive the money may deposit it back in the same bank because they are customers of that bank. The credit expansion which follows is indicated by the formula on page 202. As you can see, it is rather complicated, but it yields a result larger than 900,000 units. Based on our example, in which the reserve ratio is 10% and the proportion of unused loan funds is 20%, or Z pays out all the money but 20% of it returns to the bank, because those who receive the money are customers of that same bank. The expansion which follows is not 900,000 additional monetary units, but 1,097,560. But let us consider the case of a sole monopolistic bank, which is very simple, because it is the case in which K is equal to 1. As there is only one bank, and we all use the bank, we will assume we all use the bank, even if I am a supplier of borrower Z and the company pays me, I immediately deposit all that it pays me back in the same bank. And that is important, because when K is equal to 1, this formula is drastically simplified. It is as if there were only one bank in Spain, the Banco Santander Central Hispano Bilbao Vizcaya Argentaria Popular Sabadell, etc. Incidentally, as a digression, the larger K is, the greater the capacity of banks to expand credit and generate fiduciary media, since K stands for the amount of money which returns to the same bank, and 90% of the money which returns can be lent again, and so on. This explains the overwhelming tendency among private banks in a fractional reserve banking system to merge. Do not think this happens on a mere impulse, to make banks larger, or to put them at the top of a ranking. Merging is enormously useful to bankers. The aggregate of the expansion which the Banco Bilbao, the Banco Vizcaya, and the Banco Argentaria could bring about separately is far less than what they can bring about together, since merging greatly increases the chances that when banks expand credit, those who receive the money will also be customers of the same bank. The same is true of the Banco Santander and the Banco Central Hispano. So, the ideal of all private bankers is to be monopolists, because then they have no problem, since they know that whatever they generate from nothing will end up returning to their bank. Let us consider what happens if this situation arises. We will all see very clearly how the process of credit expansion and money creation takes place. Now then, at moment T1, there is no problem. Mr. X walks into Bank A with his €1,000,000 and deposits the money, and Bank A makes the accounting entry we have seen. The bankers put the money into the vault and record 1 million cash. Demand deposits 1 million. At moment T2, what does the bank do? We will not elaborate on it any further, since we have been studying it for 3 chapters. The bankers give in to temptation, perhaps legally, because they have already obtained the privilege, and they take 900,000 and loan it out. So 900,000 loans to Z. Cash 900,000. 900,000 comes out of the bank's vault, and Z pays a number of people a total of 900,000 euros. But because Bank A is the only bank, and thus monopolistic, everyone who receives part of the 900,000 euros deposits the money received back in Bank A, and that is what happens at moment T3. The entry made is 900,000 cash. Demand deposits made by A, 900,000. The entry made is 900,000 cash. Demand deposits made by A, 900,000. The bankers say, what are we going to do with 900,000? We will appropriate 90% of 900,000, leave 10%, 90,000, in the vault and loan out the rest, 810,000. There you have the entry 810,000 loans to V, another company, and the 810,000 leave the vault when V makes payments. But since there is only one bank, what is done by all of those who are paid by V part of the 810,000 monetary units? They deposit the money back into Bank A, and that happens at moment T5. 810,000 cash. Demand deposits 810,000. And why should 810,000 sit idle? Ask the bankers. Let us appropriate 90%, 729,000, and lend it. The money comes out of the vault, and when the suppliers of Company Y receive the 729,000 units, they deposit it back into the bank, and so on. And do you know what happens as a result of all this? Well, the deposits of the monopolistic bank are equal to the 1 million originally deposited, plus 900,000 in the second round, plus 810,000 in the third, plus 729,000 in the fourth, and so on. This is the sum of the terms of a geometric progression. The terms increase and have a common ratio of exactly 1 minus the reserve ratio. As we can very clearly show, the result is that if the sole monopolistic bank maintains a reserve ratio of 10%, or 0.1, it can increase the money supply tenfold. This is the simplest and most universal formula used to represent the bank multiplier. Deposits divided by the reserve ratio. In our example, 1 million euros or monetary units divided by 0.1, which equals 10 million. And this is the most simplified version of the bank multiplier formula, which Alfred Marshall, an English economist, had already intuited back in 1887.